Welcome to the Computing There I Was podcast. I am your host, Richie Bilak. In this podcast, we'll have conversations with veterans of the computing industry to hear about their adventures. Hi, welcome to the Computing There I Was podcast. I'm your host, Richie B., and today we're talking with David Lampell. David is a software engineer who recently retired from Google. We worked together for a couple of years. Hi, David. How are you?
I'm good. How are you, Richie?
I'm great. So I will begin with the question I ask everybody is, how did you get started in computing?
I got started science fair projects, believe it or not, in high school.
Wow.
And I got involved in some of the digital circuitry back when. And then I can't remember, it was 67, 68, somewhere in there. No, it had to even be earlier than that, I think. But my father bought an Olivetti Programmer 101 for use in his...
What is that? What was that?
It was shown in the World's Fair in New York City.
Right.
And it was made by Olivetti, and
Right.
they ended up calling it a smart calculator or a computing calculator or something of that nature. They couldn't call it a computer, but it was basically a personal computer.
Oh, I see.
You
Okay.
programmed it in machine language. It had a magnetic card that was about the size of a dollar bill. And
Interesting.
and it did digital arithmetic because it was designed to be a calculator.
Okay.
Think of a very smart adding machine. And it had a bunch of registers, not that many, and each position in a register held either a digit or an instruction.
Okay.
So you could sort of share, if you knew your numbers weren't going to get too big, you could play all sorts of games. Anyway, I learned to program that.
So where did you go to high school? This is New York City?
No, I was in Poughkeepsie, so I went to Poughkeepsie High
Poughkeepsie.
School.
Oh, okay. Right next to IBM.
Yes, but and there's some interesting stories about the Olivetti, how basically IBM and the CIA killed it because they didn't want computing in everybody's hands.
That is interesting.
And so this is, a big predecessor of PC. So I started small.
That's interesting. Machine code, so it was just like add instructions like add register 1 to register 2 or some such like that?
I can't even say they were that clever. I mean, they had all these weird symbols for the instructions, like up arrow, side arrow. But yeah, basically you were adding things together. They probably had an accumulator. It wasn't that luxurious. So you probably made something an input and added it or did something to the accumulator, something of that nature. And my father figured out that he could automate insurance calculations, premium calculations for automobiles and houses because they were all those tables had a formula behind them.
Right.
So he was not particularly interested in selling insurance, but he was much more interested in writing the programs.
Right. So what happened next?
Well, then I went to a National Science Foundation summer program at Stevens Tech in Hoboken.
That's Stevens and Hoboken, right?
And I learned Fortran 4. And at that time, PL1 was not really, I don't know, it was totally functional, but there was enough of it, we learned some of it.
Did you get to use PLC? Because that's kind of what I used when I first started computer
Well,
science.
I got to PLC later.
Okay.
So anyway, I came back to high school, and my school system had bought an IBM 1130 to do administrative work, but they figured they'd let students learn to program.
That's cool.
Well, it turns out that I had to teach my teachers because I was the only one who knew how to program. You know,
That seems
this was
to.
all punch cards.
So did they get a punch card machine as well?
Well, yeah, they
A
had
key
some of
punch?
they had a Mark Sense reader, and they had, those old collators and sorters, things
Hmm.
for when you did data processing on cards, as
Right.
well as the computer. So yeah, we had an 029 key punch.
So what did you program that? Was that still assembler or machine code?
That was in Fortran,
Oh, that's Fortran.
but I got interested. That Fortran that they had didn't have a logical if statement; it only had an arithmetic if. So I spent time, and somebody at IBM gave me the microfiche of the compiler, which was, of course, all assembler.
Right.
So I spent a project trying to figure out how to modify the compiler to add logical if statements.
So what is a arithmetic if statement? So it's just like if you get
No,
the
if the
arithmetic
value was
expression.
zero, less than zero, greater than zero.
Oh, I see. And logical, you would have a comparison.
Yeah, equals, greater than, less than type
Right.
thing.
Mm.
And I don't know why I was annoyed, probably because the Fortran I learned had the logical if, and then I
Right.
showed up and it didn't have. And you know how everybody is at that point. You can figure, oh, I can fix this.
Right. Of course. So did you?
Well, I figured out how to do it. I didn't actually do it because I
Right. You would
didn't
have to
have the
change the
source
compiler.
code in any manageable form. But that was my science fair project for the year.
Oh, so that's cool.
I,
What kind of program did you write?
I wrote about how I would fix it,
Oh, I see.
how I
Oh,
would
that's cool.
modify the compiler to do what it needed to do. And the feedback I got was, you must have had help because you couldn't have done this on your own.
Well, you did get the source code fiche, right? So that was
Well,
helpful.
I told people I had that.
Right.
Anyway, so then I graduated high school,
Hmm.
and they paid me to write the high school grading system before I went to
Excellent.
college.
You mean before you went to college?
Before I went to college.
Right.
Um,
Nice.
so I wrote it in Fortran,
Okay.
the Mark Sense cards. And, in retrospect, I learned two very important lessons. N squared sorts are really slow. And I learned that call by value in Fortran allowed you to actually change the constant 1 to be the constant 2.
Really?
Yeah, I actually view that as a bug in the compiler.
I think so. So you mean when you're thinking you're passing a value, it's actually passing a reference
Yes,
or something?
yes, and it changed the constant.
Yeah, I've worked in a language called Bliss a little bit that allowed that kind of stuff, which is kind of bad.
Yeah, anyway, those are the hard lessons you learn.
Right.
As
Those are fun debugging lessons. Yeah.
Right, being self-educated, you learn this stuff. And then I went to college and actually learned how to write software.
So which college did you go to?
I went to Cornell Engineering.
So same as Eric.
Yes. And Cornell, when I was first started, had a language called CUPL, Cornell University Programming Language. I don't remember anything about it other than that. Shortly after that, we switched to PLC.
Okay, right. That was so PLC was the Cornell version of PL1.
Yes, it was a load and go, and it fixed your bugs. And the time I was in graduate school at Cornell, I was interacting with the people who had to maintain it and were modifying it. And we would use the CS100 students as the guinea pigs in the new compiler.
Yeah, I remember, so when I was at Brooklyn College, this is like 75, we used PLC for, computer science 101. And what I remember from it is that it tried to fix your errors. So like if you forgot a semicolon or something, it will put it there. But every now and then, like when it tried to fix your errors, we'd make things a lot worse.
Yes, but the philosophy behind it was, again, this was back in the days of cards and batch processing. And prior to that, the students, when I was an undergrad, we had experienced in our freshman year, you'd put your program in, right, to be run at some point, and the system was so overloaded and the operating system was working so poorly, you never got it back. So PL1 was designed to minimize the amount of repeats by trying to fix your stuff. Well, if you screwed
Right.
up a declaration statement of your variables, it would fix it, but it would not make any sense. But you're right.
Right.
Simple syntax stuff it could figure out and fix for you.
Right.
And also, as it ran, when it hit errors, it would say, oh, you're out of range here, and this is the value, and I'm going to use this value and keep going, so maybe you'll get more information and maybe you won't. But the idea was to try to minimize the amount of repeated runs that you had to do.
So what was your major?
I majored in general engineering because there was really no way to major in computer science. So I wrote a curriculum that I did a little mechanical, I did some electrical, and I did a fair amount of computer science courses.
So what kind of computer science courses did they teach? Did they teach like, what today we would call data structures and algorithms
They
kind of
did.
stuff?
There was, I think that was 609, and they taught, PL1 or
Right.
programming using PL1. They taught assembler,
Right.
360 assembler, which was a piece of cake because I had done stuff, so I didn't have any problem with it.
Yeah, I did the same. So like at Brooklyn College, when they did the architecture course, that was basically programming in 360 assembler.
In the electrical engineering, there was a architecture course, which I took, and we studied how crays were put together and how IBM 360 used microcode, and we played with the
Right.
microcode a little,
Oh, that's
as
cool.
thought experiments. And the lab component was you were supposed to use, you partnered with somebody, and they had all these modules, and you were supposed to wire them together. I had like an adder module for a bit, things
Hmm.
of that nature. And we're supposed to make a machine that adds, subtract, multiplied, and divided. My
Okay.
lab partner and I looked at each other and said, binary is too easy. So we decided that we were going to do base 4 floating point because IBM at
Okay.
that point was using base 16 floating point, and we figured we would learn a great deal.
And did you?
Oh, yes. And the one thing we did learn is that when we ran out of hookup wire and we're using speaker wire and jerry rigging it, we had so much noise, we had to turn off the fluorescent lights in the lab.
Oh, that's pretty funny.
But then we sat down at APL terminals and simulated our design.
Oh, okay. That's cool.
So, we proved that our design worked, but we never actually were able to realize it because of the limitations of the test equipment. Well, and anyway,
So,
this was a diversion from the, like what did they teach? So I took the data structures course.
mhm.
It was based on Knuth's Volume 1, I think.
Right. Yeah, it's on my shelf right here
Yeah, it's
somewhere.
on mine. And I audited that course as either a sophomore or a junior. It's like I didn't know what I was doing. I just sat in on it. And that
Hmm.
summer I read the textbook. I read Knuth. And it's like, okay,
Yeah,
now I know
yeah,
data structures.
yeah. That book is still
It's still
relevant,
relevant.
I guess. Yeah, yeah.
And I took assembler and I took another course where we learned Snowball
Right.
and
So
we learned
we had like a
Lisp. And then we had
right.
to write a Lisp interpreter in Snowball.
I took a programming languages course, which included a little bit of Lisp, a little bit of Algo, a little bit of Snowball.
And
Did you ever use Snowball beyond the class?
yes, actually, when I was at Smarts, we had a piece of code that was Snowball that laid down code that we
Hmm.
then compiled.
Yeah.
And at that point, they were using Spitball, which was a Snowball variant.
Right. Right. Spitball was a version of Snowball developed at NYU by Professor Doerr, and it was meant for students, which had one limitation that they can only execute so many statements, like 32,000 or whatever.
Right. But it served the purpose for this particular project. I think that's how we laid down the client API code to talk to the servers.
Yeah, code generation. Here we go.
Yeah, exactly. I mean, it's like I had done this before, so this was no big deal.
It's kind of funny because I did something very similar with Spitball when I was a junior programmer at Irving Trust Bank. They gave me this what they call table subsystem, which is basically a bunch of constant tables like currency codes, country codes, stuff like that, with a lookup function. And as a junior programmer, I had to code all the constant statements, in assembler, and then sort the table so that the search would work properly. So I had Spitball. I said, I'm going to write code to generate all this stuff, and I did. So that was pretty funny. So you said you went to graduate school?
I went to graduate school. I studied operations research, but it was heavy in computer science.
Still at Cornell?
Still at Cornell. I took the compiler course there, so I learned to write compilers. Served me well many times.
Right. What is operations research, like in 25 words or less?
It's really a study of algorithms and how you apply the techniques to real-world problems.
Okay.
So one of the examples was with dynamic programming was laying out components on a circuit board to minimize the interconnects.
Oh, okay. Oh, that's interesting.
Or how you solve the traveling salesman. So you get into NP-complete problems.
Right.
So it meshes really well with computer science.
I think I did a little bit of that where I took a course like in simulation where you had to, we simulated things with queues and like processes and see what would work well or not. I remember we tried to decide what the best algorithm was for moving ahead on a disk drive, how to seek, when you get a request, that kind of stuff.
Yeah. So I ended up with a master's in my master's project. And at the time, AT&T was basically the Bell system, right? And that was your phone system. And the university was spending like $60,000 a month on toll calls.
Right.
And so they had bought something called a Watts box.
Right, I heard about that.
When you had an interface to it, because you couldn't directly connect equipment to the phone system at that point. You had to go through a couple hardware interfaces. But basically, it had a set of lines, and when you made a long-distance call, it went to the Watts box, which then selected a line to put your call out on. And the idea was you could minimize your long distance.
Right.
By using Watts lines and whatever. So the project was now pick the lines to minimize the phone bill. So it involved reading the toll tape to find out what the traffic was, where it was going, and how long it was. And then it was pick a set of lines, basically. So we gave it a bunch of, there were different types of Watt lines. There was just regular direct dial. And we recognized that a lot of the traffic was going to New York City. And you could buy a foreign exchange line. Basically, you paid for a New York City phone number in Ithaca, New York.
I see.
So, think of it as a dedicated line, and you could just
right.
phone calls over that. It actually turned out that because of some peculiarities of the tariffs, it was cheaper to have the FX line, two of them, going through something in Pennsylvania because of stupidity of the tariffs.
Yeah, it's always something like that.
But, we were able to save, the Watts box knocked it down to 40,000, and then we were able to save another 10,000 a month.
Oh, that's nice. So you were doing this still as a student, or
were
you
as
an
a
employee?
Student.
So what happened after graduate school?
My father, I told you he was involved in this writing insurance software. So I joined him because Olivetti at that point was making small little personal machines that were married to typewriters if you wanted.
Uh-huh.
And so we were in the PC revolution before there were PCs.
Yeah, that's very cool. I vaguely remember Olivetti. So you work for Olivetti actually, or?
No, we didn't work for Olivetti. Had a company, but Olivetti had a good relationship with us in the U.S. because we were moving their hardware into places that they never thought of going into. At one point they were making banking terminals. Well, we realized that banking terminals were perfect for people in an insurance office or in insurance companies.
Right.
Policy production. Basically, it was a small screen keyboard. You could add a printer, right? There was storage. I mean, basically, that's a PC.
Right. I'm gonna find a link on the web and include it like in the show notes so people can see it.
Okay.
I'll run it past you before.
Sure. Yeah, I mean, Olivetti's dead at this point, but
Yeah. No, I remember the name, and I remember.
yeah, Bank of New York or Irving Bank had a whole bunch of Olivetti terminals at one point.
Probably.
The banking terminal.
And so this was all programming. The Olivettis were just basically programming like in assembler or machine language, right?
Yeah, they were in assembler language. I mean, the later ones had, I guess they had floppy disks. At one point, we had used one piece of hardware that simulated a disk with a tape loop, hermetically sealed, and so seek times were in seconds.
Hey, it's still faster than putting cards in or something.
Well, we learned to ask the user for an input while we were moving the tape.
Right.
So they never saw it.
Nice. So how long did you do that for?
I did that for a while, and then maybe 5 years, and then Olivetti was coming out with a PC at about the same time IBM came out with a PC, except theirs was based on a Z8000 chip.
Right. So like CPM was.
Well, it wasn't CPM because it was 16-bit.
Okay.
And they had an operating system that I don't know whether they wrote it or Microsoft wrote it or a combination, but they had something. They had a basic that basically became the GW basic, all the graphics stuff.
Okay.
They had that before the PC, and they literally hit the markets about the same time. And guess which one succeeded and which one didn't. But I ended up writing for them an 8-bit emulator that ran CPM and emulated a Z8000 chip so they could run all the CPM software.
Oh, cool. I remember, what year did the PC came out?
It came out in 81.
Right, the early 80s. No, I remember going to like all these stores playing with the Trash 80.
Oh, yeah. I had so much fun with the Trash 80s. I used to go into the store and lay down a little basic program that would scroll in a pattern on the screen, buy me a piece of trash, right? And walk out.
Yeah.
And so the solution to the stores, or the Radio Shack stores around here, was to put up a sign that says, "Do not touch our computers," defeating the whole purpose of having them on the floor.
Right. Yeah, I used to be into writing little programs that computed prime numbers, so we just print them as far as it could go.
Anyway, after that, I moved on to a company that wrote medical software. It was PC-based.
Okay.
And what we were doing was talking to the analyzers in clinical laboratories and gathering the results. Because when you have blood work done, it's usually spread out to multiple machines.
Right.
Right? They take multiple tubes, so they're going to different machines, but you want one consolidated report.
Right.
So we dealt.
That's interesting.
We dealt with all that, and you're supposed to approve the result as the lab tech, and as the machines got more, some of the machines got more interesting. They had pipetters, and so you could actually say, okay, this tube. We'd read the barcode on the tube. We would tell it what tests it needed to perform. And so all that was real-time programming. So we had a real-time operating system running on top of MS-DOS. And we were running 70 programs simultaneously on a PC.
So how much memory and which version of the Intel chip was this?
Uh,
Do you remember?
we we
Was it
did it before.
Pentium
We
yet?
did it before 386s, before Pentiums. Pentiums made our life a little easier.
Yeah.
But basically, we used the LIMS extended memory.
Uh-huh.
So as we swapped tasks, we swapped memory.
Right.
So we partitioned memory and said everything above 256 was task memory. And then we got to the point where when we wanted to send messages, we would say, oh, that's a page, a LIMS page, and we will literally map it from one process to the next.
So you actually connected to the lab equipment that was doing measuring,
Yes,
or
RS-232. So we got really good at writing interfaces. And yeah, the machine came with, I think, two RS-232 ports, and we ended up using either 4 or 8 multi-port cards in the PC. And we had to service those interrupts quickly because RS-232 is not that forgiving.
I didn't work quite at that low level. So how did you debug this stuff?
Well, since we had our own kernel to do this stuff, we ended up writing a debugger that we would dump everything to memory in a known format, and then we wrote a program to allow us to go through and examine memory.
Oh,
So we
could
could
you
look at
step
our
through
semaphores, we could look at our messages, we could look at who was waiting on what.
Okay, so it's just like
It was all
what's that called?
post-mortem.
Postmortem dump. Any interesting stories
Yes,
of
we
bugs?
had one bug that we couldn't find. And every time we did diagnostics in the kernel to try to find it, we slowed the kernel down so badly because single threading through printf, right? And I'm working with another customer, and we begin to see something weird, but I realize it's a reproducible scenario. So now I got a way to go after this problem that we hadn't been able to find. And I set up a rig where we were just hammering our multi-port card with interrupts, right? So you're just things simulating analyzer, just dumping data out, and sure enough, it would fail. And I was able to trace it back. It turns out it was a bug in the compiler's library that when it simulated interrupts, it forgot to turn off interrupts. So we were in interrupt handling routines that assumed interrupts were off, but they weren't. And we were corrupting our kernel data. So the original customer, when we fixed it, we told them, oh, we have fixed this. And they used to get a message that was getboot 02, which was short for problem with get buffer.
Right, okay.
And they said, you're going to guarantee we'll never see this message again, right? And I said, you will never see the message again because I had changed the contents of the message.
Right.
But they never saw the message again.
Right. So this was you were coding in C at this point, I
This
presume?
was all in C with the drivers for the card. Those multi-port drivers were in assembly.
Of course. Who did the C compiler?
We switched from Microsoft C, the original Microsoft C, which was somebody else's. I think it was Brain Dead Software or something, C compiler.
Yeah.
We switched to the Watcom compiler.
I heard of that one.
And that's the one that had the bug in it.
Oh, okay.
In the library. But it was a better compiler in many ways other than that one bug that took us. Anyway, that was my favorite, what was your favorite bug and the hardest to find? Well, that was it.
Yeah, I have a couple of stories along those lines. So you did this for a while, and then what happened when the internet came along?
Well, that's the problem. We were doing this, and we had just moved on to expanding to do on, remember Windows CE devices, the little handheld, the Palm Pilot type things?
Yep.
We
Yep.
figured out how to do Medicare Part B for doctors, all the coding
Uh-huh.
and the note taking and all that on a Windows CE device.
Oh, that's cool.
And we were looking for funding. And this was just about the time the dot-com world imploded,
Oh, so this is in the 90s now, end of the
end
90s.
of the 90s. And this guy from Intel comes and says, I do, I look at companies and I specify them by either East Coast or West Coast. East Coast companies have wonderful product and no marketing. And West Coast companies have wonderful marketing and no product. Which, if you remember the dot-com world, that's
Yeah.
exactly what was going on. And they said, you guys have a wonderful product, but you are too small for us to invest in you.
Yeah.
And basically, we ran out of money at that point. So it was time to find another job.
So where did you go?
I ended up at System Management Arts, better known as Smarts, which was a network management company.
Okay.
And what it would do was pinpoint the fault in your network by listening to symptoms.
Okay.
There were other people trying to do it, but they had a way of modeling the network, so that if we would walk through and discover the network.
So this was we talking about TCP/IP networks at
Yes.
this stage, no?
TCP/IP networks. We could crawl the network, the routers, the switches, all of that equipment, find all their
Nice.
connections. We could model them, and then what we would do is we would listen for symptoms, because the device that's having a problem can't tell you it's having a problem.
Right.
It's the devices that are connected to it tell you things aren't right. And we were able to pinpoint where the fault was. Now, our competitors at the time were writing rules based on knowing what the equipment was and how it was connected together. Well, networks are constantly changing.
Right.
So that doesn't really work very well. And that same technology we were then able to apply to applications and also optical networks and some other networks. So our customers were people like AT&T and British Telecom, Microsoft.
That's nice.
That was C++ code.
C++, the early version of C++, I played with one little bit, like I guess in the late 90s maybe, before it had multiple inheritance. Did you have?
We had multiple inheritance.
So which compiler did you? You didn't use the
Well,
Cfront.
no, we weren't using Cfront. That code, we compiled the code for Solaris, 2 versions of HP OS,
Right.
HP Unix, AIX, Windows, and Linux. So it was one code base that got compiled to all of those.
So actually, that's an interesting question. When did you start using Unix or flavor of Unix? Because
That's
in the
when.
medical stuff. Oh, I see. So when you moved to the networking.
When I moved to the networking company, I learned Unix and I learned pthreads because it was heavily multi-threaded.
Of course.
But since I had done all this other work in the real-time system, conceptually, it was not a hard jump.
Right.
Although I had to learn TCP/IP and SNMP and all sorts of other things of that nature.
How down low did you have to go with the TCP/IP stack?
Well,
I guess pretty low, right?
Well, I ended up working on the foundation group, which is basically the lowest level was where we had different. Well, it was the build system to some extent, which was in Perl. So we could pull together different pieces based on which operating system.
Right.
And then at the lowest level of our code, we had different pieces for different operating systems to make them all look the same.
Right.
So trying to make Windows multitasking look like Unix pthread stuff was an interesting challenge.
Yeah.
But we did it so that the upper layers didn't have to know the difference. So it was
Well, this is like a standard engineering thing, right? You build an interface and
right.
hide the details.
But so it was a combination of macros and bringing in different modules, during the compile time.
What did you think of C++ and object-oriented programming in general?
It made sense to me because we'd been simulating that in C earlier in the previous company. Not quite as well defined. And we looked at C++ to see if we could use it. And we had a project that sort of failed because it was not C++, but it was sort of the management and also sort of the people who were doing it were trying to use too much new technology they
Right.
didn't know.
Yeah, it's I kind of felt the same way, like when this whole object-oriented thing came around, saying, "Oh, that makes sense to me." The funniest thing about that is that, like in the 90s, I went to some conference at the Marist University in Poughkeepsie.
Yes. Well, it was Marist
And
College at the time. Now it's Marist.
right, right,
They just
right.
changed the name to Marist U.
And the guy, remember there's a guy who wrote this series of books called Effective C++.
Yes.
So he gave a talk. This was like early on when he gave a talk about Effective C++ before having written the books. And there were a bunch of what to me at the time looked old guys from IBM, and they were just kind of saying, object-oriented programming, poof, we've been doing this forever. This is just control blocks. And I thought they were off the kilter, but in fact, yeah, they're right. It's like, if you look at the 360 operating system or the low-level APIs for 360s, it's all like functions and control blocks, which is essentially, if you put them together in one package, would be a class or an object.
Right.
So
The difference, and we had been doing that in the C world to make our life easier.
right, right,
Our interfaces ended up
yeah,
being, to the analyzers ended up being 4 programs, but think of the programs as to some extent objects.
right, exactly. Yeah,
But the project that failed was trying to do things like, oh, we need a state machine. We'll make each state an object. Well, no, the state machine is the object.
right.
That's what they misapplied the technology.
Yes, I've seen that as well.
And again, that was sort of, the first project learning experience. But they tackled too many things at the same time and got lost in the weeds.
So what happened to you during the dot-com crash?
Well, I lost my job, obviously.
Right.
Came home. I was in Dallas. I came home, or actually, I didn't go out to Dallas. I said, "Don't come because we're not sure we can afford to pay for you to get home."
Nice.
So okay, fine, I get that. So that's when I found the other job. But in between, it's like Marilyn says to me, "Well, what are we going to do?" I said, "Well, we're going to London for Thanksgiving." And so off we trucked to London for a long weekend.
Oh, that's nice.
And then I started the next job pretty quickly. So that wasn't particularly hard. And then Smarts got bought by EMC, which had one good benefit, that my stock option was now worth something. But they bought it. Looking at what they did, they bought the company for its revenue stream, not its technology. So they were milking it. EMC was a storage company.
Right.
And eventually, after I left, they finally made a storage product because their storage was a network. So they used the Smarts technology to manage that network. But they went out of their way to get rid of the smart people and just milk it.
Yeah, I've went through a couple of these takeovers where one company bought another. But so did you get to use Java at any point, or some of the internet stuff, web stuff, or?
Yes, at Smarts, one of the things we had was a front end GUI, which was in Java.
Mm-hmm.
So one of the first things they asked me to, and we would lay down with that Spitball program, the Java API code, the client code, right? So Java could call to the servers, but they asked me to do something with JNI
Right.
so that we could launch the Java code from C or C++.
Right.
So I learned JNI and I figured out how to do all that for launching the GUI and doing all sorts of weird things. And then I worked on, because EMC was a Java house and all of our model stuff was, remember I told you we could model like the routers and things?
Right. Uh-huh. Uh-huh.
Well, part of the implementation of those models was traditionally in C++,
Right.
and they wanted to do it in Java. So we used the JNI stuff so that you could implement the model code in Java and move stuff back and forth between Java and C++ for them.
Right.
So I spent a lot of time laying down Java code from C++ code, but never actually using Java
That's pretty funny.
until I got to Google.
So how did you wind up at Google?
Well, I read the handwriting on the wall that I was in line to get fired from EMC. About the same time, I got approached by somebody who had worked for me, who was then working for one of the large banks in New York and was doing computer security. And since I had done a lot of computer security at Smarts, including writing low-level algorithms ourselves like RSA and DES
Oh, really?
and Diffie-Hellman key exchange code.
Right. Right. You actually wrote that code?
We wrote all that code because we needed it to be multi-threaded, and there was nothing that was multi-threaded at the time.
Also, the libraries you could get from RSA were not multi-threaded?
Correct.
Wow.
And
Okay.
since we were heavily multi-threaded, we did it ourselves. And used the test cases from NIST to prove that it all worked. And so I do a fair amount of computer security at that point. So he was working at a bank or managing the computer security at the bank. So he reached out to me. I went for the interview and he said, "Oh, go see Jerry. Remember Jerry Lecter?"
No, I don't.
Okay. Anyway, he came from Smarts and he was at Google at the time. And so I went down to Google and chatted with Jerry, and Jerry says, "Apply." And this was 2010.
Okay.
So I apply, and I end up with offers from both Google and a bank. And I go,
Hard choice.
yeah, not a hard choice at all.
So you always worked in the New York office then, right?
For Google, yes. And I joined, I was an SRE. I knew nothing about being an SRE.
Just for people who don't know, can you explain what SRE is?
Site Reliability Engineering. They're the people who basically make sure that the systems are running, figure out how to monitor the systems to keep them running, figure out how to provision systems on the fly, spin up new instances, and when something goes wrong, they're the people who figure out how to fix it quickly.
Right, you get the beeper call.
You get the beeper call.
Well, kind of makes sense because you spend so much time doing network monitoring. So
Yes.
Google has a rather large network.
Right. And I actually think Google probably played with Smarts technology at one point, although Google's network was way too large for it. I mean, at AT&T, we needed 400 servers to monitor the network. And AT&T says, we need 5 nines of reliability. And we're going, our servers are running at 5 nines of reliability, but you have 400 of them. So you no longer have, something's going to be failing.
Right.
Right? It's not that it's not reliable, but something will be failing. I mean, and that's sort of, Google always had that philosophy. Something's always going to be wrong or breaking.
Right.
And,
Right.
a lot of large numbers.
So how long were you SRE for?
Well, I was there. I was in corporate engineering SRE, and I was in the group that was in charge of running the CorpDB database,
Mm-hmm.
which we eventually got rid of because we didn't own the data. But also we were in charge of provisioning accounts when people were joining Google. So one of the things we did was 2 to 3 days before people joined is we set up their account. We got them their
Right.
email. And so basically when you walked in and you set your password, you were active and ready to go, talking to a variety of systems. And we automated all of that.
Oh, what did you use? Did you use, I think that Google used Python for most of that kind of stuff,
That
right?
was a Python shop. So I showed up and had to learn Python, of course, because
Well,
it's Google and you just learn something new. And then the CorpDB stuff was in Ruby on Rails.
that is funny.
And since I knew IPv6, I got charged with fixing the IPv6 implementation in it. Accounting of things because it kept track of all the network connections.
Okay.
And that's the point where we were running out of IPv4.
Right.
We needed IPv6 to be functional.
Right.
So the accounting side for IPv6. So I ended up doing that. So one of the things I did at Smarts was the original system did IPv4 networks, and we had to be able to do IPv6 networks. So I was sort of oversaw the low-level work to support IPv6.
One thing that I like to ask everyone is like, if you were advising somebody who's trying to enter the field now, what would you tell them?
Well, I think you have to learn how to learn because everything's always changing. You're always learning something new. And to some extent, what's old is new again. There were simulated languages way back when, and we moved away from that, and we moved to PCs that were standalone, and then we went to internet, and now, like, to some extent, you fill out a form on the internet, and you release it to the server, and the server comes back and tells you what you did right or wrong. Well, how is that any different than an IBM 360 with the 3790 terminal?
Right. There's probably more steps in between the terminal and the
But
computer, but you're right.
But logically, that's what you're doing, and
Yep.
we walked away from interpreted languages like BASIC, right, to on the iron like C and maybe C++
Right.
for optimization, and then we walked back to them with Java, with the virtual
Well,
machine.
right. So there's Java and Python and that um, family. On the other hand, there's Rust for people who don't quite want to learn C.
Right. But I guess what I'm saying is that pendulum swings back and forth based on the technology
Yeah.
of what we can do and how fast you can do it and what's easier for people to work with. And certainly what I started with and how you maintain programs, think assembly code, for example, and what you do
Hmm.
now to maintain programs and system engineering and make it. It was pretty humbling with that medical software in the clinical labs. That stuff ran for 25 years.
Wow.
You get a real sense of, oh, stuff lives a long time. And oh, by the way, crashing the program is bad, but misreporting a result probably killed somebody.
Uh, I always, everybody wants to, develop, write code and develop new systems, but any successful system is going to be around for years. And, maintenance is probably more important than initial development.
Right. And it's not just maintenance. It's the fact that it's going to need to be refined, evolve, and add features to it.
Right. Also, stuff changes underneath it, so it's
Exactly.
kind of
I mean, we had to figure out with the medical software how to run boards that were supposed to be automatically configured by the operating system when we were running an operating system that couldn't do it. So we had to figure out how
right.
to say we're using these boards and this is how we're configuring them, and learn how to program all that stuff because we couldn't move the software, although it would have been nice, but we were never able successfully to fund a project to move the software to a newer platform.
What is your opinion of all these AI tools that are around? Did you get a chance to play with any of them, or?
I haven't played with them much. I played with them while coding in Cider at Google. And
Mhm.
sometimes it was helpful, and sometimes it wasn't. My opinion is it helped me because I didn't have to look stuff up, but sometimes it would lay down code and I'm going, what was it thinking? And I go back and look at, I didn't write that. Where did that come from? And other
Right.
times, if you were doing sort of routine editing, it could anticipate your pattern and do a whole chunk for you, which was nice. I was talking with my son's wife's father, who's
Okay.
teaching computer security. He says, I love AI generated code because I can put together simple programs by letting it write the particular algorithms and I just have to connect them together. I'm not sure that makes sense. I always liked being the person who's enabling the AI to do its thing or building the tool to do the thing, right? I always like to be behind the scenes.
Right. So I have similar experiences. For our listeners, Cider is the Google's internal IDE that we can use to write code, and it has a plugin for a coding agent that can help you. And you can ask. What I found that useful is I recently had to kind of dive into a large pile of C++ code and trying to understand how it works to add some small feature. And Cider, the agent helps you, right? So if I'm looking at all this code, I can say, says, how does this code do this? And it points me to the places. But when I try to get it to write actual code, it could do some simple things. Anything more complicated would just go off the rail.
Yeah, that's my experience. And I guess the other piece of advice that I would tell anybody starting is write
Hmm.
very good unit tests that test success and failure and have large coverage. Because as you modify your software over time, they will save your butt by pointing out when you've broken something.
Absolutely. And I actually tell people that, the unit tests are the precise specification for your code, right?
Yes. And
And with that, if it doesn't have a test, it doesn't work.
right. And even just because it has a test, it has to have a negative test as well. It was nice at Google. We had coverage statistics, and it would sort of tell us where we had done things right and where we had done things we weren't covered as well as we should be, or where maybe we were missing certain conditions in our testing. But I found over time that just having a good body of unit tests gave me lots of confidence when I wanted to modify existent code.
And I've worked for some companies where testing was up there. You always wrote tests, and half the code was tests. And other companies where they said unit tests, that's what a waste of time. We test in production.
Right. I mean, it's not just a unit test. I mean, we had integration tests to actually
Right,
prove
right.
that the stuff worked together correctly. And that was invaluable because when I was doing the network, or not the network, the medical stuff, we never had the analyzers. We would work from the spec and have to then
Right.
go to the customer's site, right, to actually do the
Uh-huh.
final debug and as part of that, we would end up with a simulator of that analyzer, which we could then
Right.
use. But what the specifications are and what really exists are never the same.
Of course.
The only way to find that out was to go and sit there with line monitors and see what was going on.
Oh yeah, I remember those. I did some network programming early in my career. We used to have these datascopes where you can watch the data go past as you
Right.
send messages back and forth.
Yeah, with RS-232, we could do that. And we sort of built a special cable that took receive and transmit. And
Yeah.
put them on to receive onto two different ports, and then we could basically have a timeline of what the data looked like on the channel.
Right. Right. Wasn't quite that low level for me, but all right, very cool. So we've talked for almost an hour. Thanks so much for your time. And
This has been fun. These are lots of the stuff we talked about, bits and pieces over the years.
that's right. The idea is I'm trying to kind of preserve some of these conversations for other people because it's kind of interesting. The histories, I find it fascinating. And there's like similarities between people's experiences and also different stuff that they did.
Yeah, I find it fascinating as well. We all came to this from different places, but we all seem to land in the same spot.
All right. Well, thank you for listening, and come back for the next episode of Computing There I Was.